What is going on, YouTube? So for this week, let's learn how we can help our APIs with scaling by carefully managing how we evolve our API design. So let's get into it. So what is API evolution? So API evolution refers to the process of making changes to an API over time while maintaining compatibility with existing client applications. So this involves introducing new features, deprecating old ones, and making other modifications that enhance the functionality of the API without causing any disruption to its users. The goal of API evolution is to keep the API current and relevant while ensuring that it remains usable by existing applications. And we'll take a look at some approaches that may help us evolve our API. So let's talk about changing data access patterns. As an API gets popular, the consumers of the API might begin to use it in a way that was not initially anticipated by the designers. So let's take a look at the example of Twitter. So a few years ago, the Twitter application could only receive new tweets in real time by constantly polling the backend API. This eventually led to the REST APIs getting a huge increase in traffic and caused scalability issues for the rapidly expanding user base. And so, how did Twitter counteract this? In August 2020, they launched a new streaming API which sends new data and reduces polling. This streaming API allows developers to subscribe to selected keywords or users and in turn allowed them to receive new tweets over a persistent connection. Note that event-driven architecture is an important concept and we will discuss it in detail later on in this course. So adding new API methods, sometimes we may have APIs that are essential but are resource expensive to call and have huge response sizes. Developers don't always need all the data and may only need small subsets of the responses to meet their requirements. If the only option that the developers have is to request all the data or none of the data, the developers might end up getting full responses and most of the payload might go ignored. So the payload that's being ignored might have been expensive to compute, and if it isn't needed, then it's a waste of resources. Making changes to an API once it has been published is not an easy task, but adding a new method is relatively easy. Let's take the example of Slack. Slack had a very popular API method for its real-time messaging API called rtm.start. It would start an RTM session and return a lot of data regarding things like teams, channels, members, and so on. This method was initially designed for small teams, but as team sizes began to grow, the payload size became a problem for the consumers of the API. Most consumers were only using this method to establish connections to the WebSocket. Keeping this in mind, the Slack team released a new method called rtm.connect. This method would only return data relevant to the WebSocket session and helped alleviate the scaling and resource wastage problems being caused by the rtm.start method. So, providing options to filter the result. If an API returns a number of objects, it's imperative to consider providing options for filtering the results. This gives developers the freedom to limit the number of objects being returned by the API to suit their needs. Adding these options make our API more scalable. So, for example, if we have a date filter, the use of this is developers often only need the latest result from the requested API. Adding a date filter limits the results by the specified date. And we also have an order filter. This filter enables developers to order results by a certain property. This can help reduce the results that developers need to request and process by allowing them to specify the ordering criteria for the results and retrieving only a subset of the ordered results instead of retrieving all the results and then sorting them. And then there's also options to return specific fields. So some fields in API responses are much more expensive to compute than others. Because of this, API designers should provide developers with options to exclude certain fields. So supporting bulk endpoints. In some cases, developers must do the same operation on several items, such as adding multiple users to a group chat. This may require sending individual API calls for each operation and lead to increased latency for the client. This also might be a problem in systems of a large scale. To circumvent this, we can support bulk endpoints. Bulk endpoints refer to combining multiple calls of the same type into an array and executing them as a single request. Bulk endpoints are more efficient because they require fewer HTTP round trips. So let's once again take the Slack example. In the past, inviting multiple users to a Slack channel would require developers to call the channels.invite method for each individual user. To improve this, Slack added support for inviting multiple people in a single API call, thereby saving costs for Slack and the developers. So as you can see in this example, we have an array of users. So this saves us our HTTP round trip time. So in the code snippet, we can see that the invite endpoint has only been called once, and we're able to add multiple users through a single call instead of individually calling the endpoint for each user. And let's take a minute to review everything we've learned so far. So we have data access patterns. So if we change the way data is being called by the client, and then we have adding new methods, making changes to a published API is a difficult task. To avoid that, we can make a new API method that returns a subset of the data that the original API returns. There's also filtering results. We give options to the developer to that, or so that they're able to filter data in a huge payload so they can get the information they need. There's also bulk endpoints. Developers often need to do the same operation on different objects, and we can design APIs to support bulk endpoints to make fewer calls to the server. Is evolution the same as versioning? Evolution and versioning are methods of changing an API in order to improve its functionality, but there are key differences between the two. API versioning refers to maintaining multiple distinct versions of an API that are released and supported at different times. This allows developers to continue using an older version of an API that's known to work with their application, even as the API evolves and changes over time. And API evolution refers to the process of making changes and improvements to an API over time. So this can include adding new functionality, updating existing functionality, or fixing bugs. API evolution is a natural part of the development process and can be managed by using versioning strategies such as backwards compatibility or deprecation policies to ensure that existing applications continue to work as the API evolves. Simply put, API versioning is a technique for managing change, while API evolution is the process of making changes to an API over time. So in summary, as we can see, scaling APIs is inevitable. Our API design needs to be flexible and evolvable so that the scaling process is easier in the future. Not only does evolving the design help with scaling, but it also provides our consumers with a robust and resilient design and gives them options for implementing the API according to their needs. Thanks so much for watching. I have been kind of falling behind on my YouTube schedule. I've been kind of busy with my full-time job and things happening outside of work. And at the same time, feeling a little bit lazy, but I am really interested in learning more tech and teaching you guys. So if you like this video, leave a like and subscribe. If you have any questions, leave a comment, and I will see y'all in next week's video.